you know, use that right now, I'll send it to you every minute. Another.
Sure, and maybe we'll talk to you after the.
Yeah, let's see if we can get one. Okay, cool. Then introduce you to.
Yeah, we'll do.
Okay.
Maybe I'll call.
Okay. Okay. Oh, can you take some pictures from the back? Okay. Just take some pictures when I'm speaking and then with the slides. Okay, just do some pictures. Yeah, we can have a look. It's probably good too. Okay, let's see. We should probably start in maybe 3-4 minutes. Not at 5:30, but
As soon as you're ready, just press 1.
yeah. You guys are all ready. More than enough cookies for everybody, I think. I think you want to take it from the completely back of the room. Stand here if you want to. We'll just start in a few more minutes, okay, just in case people are still coming in. 3-4 minutes. So Bruce and Jeff, if you can hear me, we'll start in 3-4 minutes.
Thanks, Suman.
Okay.
Okay. Sorry, is that wired Ethernet?
Yes.
Oh, okay, but
The laptop's connected to
oh,
the wired connection.
what is wired? ParaDrop? Oh, nice. Okay. Derek coming back? Oh, I see.
Just want to check that it's connected to ParaDrop. Yeah.
Yeah.
It's not working.
Yeah, okay. So those of you who have joined the live feed, we are going to start in maybe a couple more minutes, so please wait for that. Ready? Shall we start, Derek? Are we ready?
I think so.
Okay.
We got Bruce and Jeff connected.
Yeah, I think they are all connected. And you should.
We can, it's already streaming.
Yeah, make sure you track the number of people. At least take some notes if we. So is this the right place to stand for the camera?
Yep.
Okay. So one.
Yep.
Okay. Good evening, everybody, and welcome to the launch event of the ParaDrop Smart Home Gigabit Challenge 2017. I am Shaman Banerjee. I'm a professor in computer science and part of this exciting event, and I'm glad all of you are here to listen to it. I will be joined in this conversation by two colleagues who are remote. One is Bruce Patterson from the city of Ammon in Idaho, and Jeff Christensen from a company called Entry Point that makes some interesting wireless hardware or home gateway hardware that will be useful for our competition. In addition, you'll see a number of my colleagues from the computer science department who are working on some aspects of the ParaDrop project, who will be doing various kinds of demonstrations on the capabilities of this platform. So the first thing I wanted to do was to give you a very brief overview of the team and the plans. How do I? This is for advancing. Sorry, which one? Doesn't seem to work. Just give, what's that?
So to give
Oh,
the focus, it's over here. Okay, so it already switched.
okay. Okay, so first thing I wanted to give you an overview of what this competition is about and who all are behind it. To do that, the first organization I wanted to mention is an entity called US Ignite. It's a nonprofit based in Washington, D.C. And their mission statement is in this slide, which says, "We foster the development of next generation applications, and through our work, we help developers, communities, individuals, and partners bring gigabit applications to life." Okay. Now that sounds very grandiose, but they actually have a very interesting and compelling mission. And if I put it in more concrete terms, they are an organization that was created through a federal initiative and has been active at least 5 years now in different ways. And they were launched in a very significant way, or the initiative was launched in a very significant way January last year at the White House. And what they're trying to do is to kind of what they call ignite various US cities or US communities to build exciting applications, next generation applications that are in a bunch of these areas which are considered national areas of national priorities. So the areas are education and workforce building, energy, health, public safety, transportation, and advanced manufacturing. Okay, so they are trying to help communities develop apps and services in these areas, and not just simple apps, but things that will be transformative, things that will probably we can kind of dream of today, but we should be able to build if we had high bandwidth networks and really exciting computing capabilities available to us. So the second partner, if you may call it that, is of course the team here in Wisconsin that's building this platform that I will describe to you a little bit more in detail, called ParaDrop, which is where the name ParaDrop Smart Home Gigabit Challenge comes from. And it's a team based in our computer science department that's been building this. And then the third key partner is folks at the city of Ammon in Idaho. And for those of you who may not know where Ammon, Idaho is, I tried to put this on this map. You see that marker on the left map, which shows you the location of Idaho, location of city of Ammon in Idaho, and a more detailed one on the right, and it gives you the impression that perhaps it's pretty close to get to Yellowstone National Park from there. So it's probably a nice place to visit. And why city of Ammon, Idaho? It'll become clear as we talk about what they have to offer in this effort. So let me talk about this challenge. So what is this challenge? So we call it a Gigabit challenge, and the reason is that we want teams to build what we call Gigabit apps. Okay, and I will explain what I mean by that. And there is a requirement or a strong suggestion that these apps be focused on either public safety or education. Okay, we could have made it broader, but we chose to go with these two areas because there is enough to do even just in these two areas. Okay, so we would encourage you to focus on these two, and we'll give you some examples, but you may not want to stick to exactly those examples, but it would be hopefully give you some ideas on what we are looking for. Okay. We do also mention that if you really have some very compelling, exciting idea that may not fit into these two specific domains, you can run it by us, and if we really like it, we can also say this is allowed and this is acceptable for our competition. Okay, so that's sort of the plan. Now, what do you have to do? So this competition officially starts today, but it's going to run for about 6 months. And we will essentially by mid-August expect to have a date where the teams will demonstrate what they have built. Okay, so it's not just a presentation, but you have to demonstrate a working system. Okay, and the intent is that this demo will run in some form of a deployment, at least locally and also in Amman, in some real environment. We'll make that environment available to the teams. And you will get a chance to really influence how some of these applications may change the life of local communities. Okay, so I think it is a very strong opportunity here. We'll also have some milestones in the middle to make sure that teams are making progress. And of course, there is prize money attached to it. So we anticipate paying out more than $15,000 in prizes. And I think more than the money is great. It will be good to win some of the top prizes. But I think we'll also, for the winning teams, will give you an opportunity to showcase your applications or your services in some very high-profile conferences that are essentially sponsored by the community, by US Ignite, and in fact the White House in some sense. And they are very nice showcase platforms where thousands of people come and you can demonstrate what you have done, motivating perhaps other cities to look and consider using it. Okay. So first question that perhaps would come up is, what is a Gigabit app? Okay. So here is sort of a definition. It's not very precise, but the goal is that this app or service, I call it an app, but it can be a service. It's not just an app on a mobile phone. It's a service that you build. That's an end-to-end service that will use or will benefit from using a high bandwidth. Okay. And by high bandwidth, I am referring to, it depends on the situation. You know, a wireless router today can actually support a gigabit per second data rate. Okay, your Wi-Fi routers at home, the high-end routers can support a gigabit data rate, and will give you an infrastructure that will support that kind of data rates. So I would expect that at least your application will attempt to use hundreds of megabits per second. Okay. You can never guarantee that you will get a gigabit per second, but at least it should, and it should do better if you are able to get hundreds of megabits per second of throughput. Okay, and we'll give you an infrastructure where that will be true. Or you should use, or the service should benefit from a very, very low latency between the mobile endpoints. Maybe it's sensors, maybe it's your mobile phone, maybe other devices in the home, and the cloud, and I put it in quotes, and you'll see why. Okay, so a few milliseconds of latency, and so that means an application that benefits from high level of interactivity. Okay, that's sort of the kinds of applications we are looking for. So if you are just thinking of a large file getting downloaded, but the data rate doesn't matter or the latency doesn't matter, that probably doesn't qualify. But if you are imagining something where, I'll just take an example, you're using a VR headset to stream large amount of data that either is coming into it or you're streaming it out to somebody else remotely observing it, and high bandwidth is important, that probably will qualify. Or you're trying to, let's say somebody is inside a home and you're trying to send data just outside and are doing some very fast response interaction that requires a few millisecond latency, that will qualify. Now remember, this few milliseconds is actually the latency between, say, a router like this right on my desk here to the laptop. Your application often requires multiple rounds of interaction between a router and a laptop to get something done. So if you have a few milliseconds of latency, usually your applications will see, say, order of 100 milliseconds to a second latency in its implementation. Okay? So the key here is that you should try to envision a service that will really benefit from an infrastructure that has either one of these properties. Okay? And again, we will provide you with the infrastructure. You don't have to build the infrastructure. You have to build an app that can take advantage of it. What we do not want you to do is to say, well, my app could just live with a 1 megabit per second latency, but I'll just use a gigabit just because I'll be wasteful. That is not a gigabit app. Okay? So it has to benefit from the extra bandwidth that's available. So I'll give you some examples first. And the context will get even more clearer as we look at some examples later on, as we get some of the understanding of the platforms. But here is one example we kind of dreamed of. So imagine that there is some emergency in a home. Okay, let's say there is a fire, or maybe a suspicion there is fire, and the smoke alarm goes off. Okay, and the smoke alarm causes, and this is perhaps what you can build, the smoke alarm causes a signal to be sent to a command center, and the command center then says, oh, maybe there is a fire in the home, and it says, turn on some specially deployed security cameras or video cameras in the home, send me really high resolution video images, very high resolution, so that I can look at various corners of the house and see if there is any fire detected in those locations, right? Because in a lower resolution image, maybe you cannot detect some things that may tell you that the fire is happening or is about to kind of start. Okay, and maybe the command center then sends some messages which says, okay, if maybe using the displays in the home or using even wireless enabled speakers in the home, it will inform the occupants saying, is there a fire? They can communicate back and forth, and you can build some interesting service that helps the occupants to either inform that they are okay or be informed that there is a problem and they should do something. You can even imagine that maybe a fire personnel has shown up outside the home, and a fire, somebody who's fighting the fire is inside, and somehow is wearing cameras on their body, and maybe streaming that to personnel who are just outside. And again, in a fire situation, the resolution of images become very important because it's very smoke filled, and the quality is a challenge, and the person's moving, and can you build something that the person who's standing outside can get a better sense so that they can decide, should I send in more people, should they go from a different direction, and things like that. Okay, so those are kinds of examples in the public safety domain. In the education domain, we have another example, and it sounds perhaps what one could actually use today. So imagine in a high school, there's lots of kids in the classroom. Somebody falls sick and can't come to class because maybe the ailment is contagious and you don't want the person to be in the classroom. But when kids cannot come to the school essentially loses kind of money they would get from the government for kids coming to class. And so they want the kids to come to class. The kid also does benefit from coming to class, but they cannot. So what do you do? In this situation, what you can do is you can give them the experience of being in the classroom, where let's say the student reports sick, they submit some kind of an automated request which generates a passcode, and using the passcode they can now log into the simplest form is a video stream from the classroom coming from a remote school into their home. Or in a more interesting setup, it could again be an immersive environment where they have this VR headset and they almost feel like they're sitting in the classroom. They can see their friends, they can see the teachers, they can see all the activities, and they have an experience of being in the classroom. And by doing that, you can kind of claim that the student actually didn't miss class. He or she was personally there. Okay? So you can build something, and what we will describe in a bit is an infrastructure where we will enable you when you have such a situation, if the bitrate of the video and the VR stream will be large, we can prioritize that stream to have a higher bandwidth compared to anything else that's going on in the network. Okay, so those capabilities will also be provided. Okay, so those are just examples, and we'll talk about some of the technology pieces. I want to talk about the timeline next. So today we are kind of launching this event. We will host a tutorial. Our planned date is March 8th. Okay, we will solidly confirm this date in a few more days maybe, and you will see the details on the website. The tutorial will help you understand how to use ParaDrop in this environment and why ParaDrop is important. In fact, the requirement is that you have to use this ParaDrop platform that I'll describe to you as part of your system, because it will help you provide a lot of the capabilities I'm talking about. Okay, and then by March 15th, which is roughly exactly a month from now, we want teams to submit a preliminary ideas. It will be a written description of what you want to do, who the team is, what do you need, hardware and software and all these pieces, and it has to be sent as a PDF. Okay, so just written description, and we will kind of say, looks good, or make some suggestions, so then you are ready to go. Okay, so we will evaluate a little bit as to whether you meet our criteria and you're going to meet the requirements of a competition. And then we will have a sort of a monthly deadline to check on you to see what kind of progress you're making, and we will give you some preliminary awards. Those will be small, but if you have said, I want to buy some smoke alarm sensors, and I want to buy some cameras, or I want to buy a VR headset, we will have budget to help you buy those things. Okay, so those will be the preliminary awards. Those will be in-kind awards to help you get equipment for doing what you need to do for your projects. And the later deadlines will also give you some extra money so that you can go and get extra stuff that you need to. Okay, so that will be early stage discussions. And then the major deadline, the final thing will be in around mid-August. We will do final demonstrations and pick winners. Okay, we'll do multiple winners, and that's when the big awards will come in the range of 5 to 10K range of money will be allocated for the final stage of it. Okay, so you can think of, we may down select a few teams as you move along based on progress. So in a way, if you're not making good progress, we don't want you to waste your time or we waste our time. So we'll help you, but we will help you keep shaping your plans as we move forward. Okay, so there are various kinds of resources that will be at your disposal for this competition. Perhaps the most exciting one, I would say, is the city of Amman has committed to making sort of the city as a test bed. So whatever you build in some scale, which will slowly grow, you won't actually get to deploy everything in the whole city initially, because we don't know if it will work, but we'll let you grow slowly and we will test it out. But eventually there's a path to get it be successfully deployed at some scale in the city of Amman, which will be amazing. There will be some special gateways that will be installed in these homes from this company called Entry Point, which will be running ParaDrop, and I haven't explained that yet, but you'll see what that does. And you have to use that capability to implement your service. So there will be a service running in your home, and then there will be services that you'll implement on a mobile phone, maybe some sensors, maybe some cloud components, and so on. Okay, and of course there will be the ParaDrop infrastructure. Okay, so the key thing I want to say is you should think big. Okay, I have said that you should build these 2 example applications, and they may be totally fine. If you like those, you can go ahead and try them out. You can imagine all the components you can actually get in the market today, right? You can get smart smoke alarms, you can get video cameras, you can get thermostats, speakers that are Wi-Fi enabled, you can get VR headsets. You should leverage those. Don't get too fancy. Don't expect to have a car, because we won't buy you a car. But gadgets that will be useful in a home context, we can buy them. So think big and find things that will make a really compelling visual demo, and that's useful and practical. Okay, so that's sort of what the competition is about. So with that, I will go in stages to introduce the different resources. So I'll start by handing off to Bruce Patterson, who's the technology director for the City of Amman's networking infrastructure, and they've done a fabulous job in the city. And I will turn it on to Bruce so that he can tell us about what the City of Amman has got to offer to us in this competition. So I guess I press 2. And with that, that's Bruce. Actually, I can see him. Will he come up here? I guess.
They will be able to see him
Okay.
on the live stream. They will be able
Okay,
to,
got it. So, Bruce, over to you. And you can tell me when to advance slides so I know. Can you hear me, Bruce?
Okay, got it. So, Bruce, over to you. And you can tell me when to advance slides. Sorry. Okay. Can you hear me, Bruce? I can. So, can you hear me now, Simon?
We have a
There's
lag.
a lag here, so
Yes.
I'm going to just try and proceed, and hopefully you can keep up with the slides. So, thank you, Simon. My name is Bruce Patterson. I'm the Technology Director for the City of Ammon here in Idaho. And if you'd just like to advance the slides, Simon, I'll give them a brief overview of what we have in the city in terms of infrastructure.
Yes, I did that.
Okay, so here we see the City of Ammon infrastructure. Just to give you an overview, we've got 33 miles of backbone fiber. It was primarily installed to support our utility operations, but we do have a number of anchor institutions online with us, which supports all of our city operations, public safety. So we have dispatch, a sheriff's annex, fire department, and public schools on there. We have 50 businesses and growing. We have 250 homes coming on. We're in the middle of our first initial fiber to the home, and that will continue through this year. So we'll actually have more than this number by the time we start to do demonstrations later this summer. Get the infrastructure. Can we go to the next slide, Simon?
Okay. Go ahead.
Okay, so this is a traditional operator network. And what I'm going to try and do here is help you to understand what is different about the Ammon infrastructure. So in a traditional operator network, we have applications that are on the edge, equipment that provides those services, and it crosses the traditional network. And you can see the switchgear through the middle there, and that switchgear is managed manually. So if we add a new service, we have to log into each one of those switches individually to set up that service. That's the traditional model. So let's look at what Ammon does in the next slide.
So Bruce, when you say that, I immediately click and you can keep going.
I'm sorry, Suman, can you say that again?
I said when you tell me to advance slide, I do that, and I think there is a lag, so you hear that later, but I always click it as soon as you say it.
There we go. So this is a software-defined network, which
I think when you tell me to advance slide, I do that, and I think there is a lag, so you hear that later, but I always click it as soon as you say it.
okay, thank you.
So this is a software-defined network. I think when you tell me to advance slide, I do that, and I think there is a lag, so you hear that later.
So this is a software-defined network. You can see the programming of the network equipment is actually managed by a controller. So think of a server and a network to actually control the network.
Ask him to mute the live stream.
So what that allows us to now do is to instantaneously provision changes to the network or new services across the network by simply issuing a single command to that controller. So this would be software-defined networking. Next slide, Suman.
You're ready, Bruce?
So what we've done in the Ammon network is actually extended that functionality, that software-defined networking, all the way to the home. So Suman talked about the piece of equipment that's provided at the home. That actually allows us to provision new services right directly to the home. This is a new feature. It's not being done in traditional networks, but we're excited to be able to do that. It means that we can instantly provision new services all the way. Next slide, Simon, and let's talk about additional features we can implement.
Done.
So what you see here is that many times when we add a new service, it actually requires a device at the premise. In this case, we're just showing a simple home router. So we end up with the operator's CPE, customer premise equipment, and then we end up with the device. And in this case, it's a router or a switch. It might be a VoIP device. It might be a streaming device. But our home gateway has the ability to actually virtualize that. So let's go to the next slide and think about what that means. When we can virtualize that device, that means we don't actually have to install a piece of hardware, but instead we just start a piece of software and get it to run on that edge device. So you can see here, we're trying to show you that visually, devices that you might need, or switching or routing that you might need, and actually be able to dynamically create that, turn it on, and actually provision it on a moment's notice. And we can also change priorities in the networks by doing that. If you look at this drawing as well, you can see that the applications, we actually have given them the ability to talk to the network controller, which allows the application itself to change the quality of the connection, the bandwidth, any number of things that it could do there to influence what's actually happening at the home. So when you think about what's being done, if you'll advance the slide, Simon, what we're really saying is, because of all of this intelligence, the ability of the application to see all of these devices and influence their programming, we've created one giant cloud service that actually extends to the home. So what we'd like you to think about as you start to develop apps is that the Ammon team, the ParaDrop team, and the Entry Point team will all be available to help you to understand how you can use your application to dynamically create a network, to prioritize it, to reserve bandwidth, and do those things on the fly based on situations that sensors will be able to feed back to your app and say, I need more bandwidth or I need this. Those are things we'll be willing to help you with. So if you'll advance the slide again, Suman.
I think that was, we hand off now to Jeff Christensen from Entry Point Networks. Jeff Christensen is the president of the company, and they build this.
So from there, I will let Jeff Christensen.
Simon, can you hear me?
Yes.
Okay, good.
Hold on. Yeah, so I think Bruce gave you a quick overview, and I think Jeff's going to talk about this special gateway. It's the hardware that we will be using in Amman, which will be using eventually the ParaDrop platform that I will describe after Jeff has a chance to talk about it. And they are a really interesting company building exciting products that are focused on the home gateway market. And Jeff, please take it away.
Great, thank you, Simon. Yeah, so we're involved in this project because we're working with Ammon providing network operation software, which is software defined and provides orchestration. Also, there's a security or authentication element that's also involved, where any device that comes in the network has to authenticate onto the network. The key piece for this demonstration, though, is the gateway that Suman talked about. And really the overall point of what we're doing in Ammon is to make it easy for a service provider to come onto this network and to have a virtual slice and a direct relationship with the subscriber. So this gateway, through virtualization and through the way we've separated virtual networks to the premise, makes that all possible. So that's the key piece of it. There's a number of elements. We're trying to move control from the network core to the edge, but the thing that matters here is that every service will have its own slice or virtual channel from the cloud to the subscriber, and that's what matters here.
Thank you, Jeff. And with that, we go back to this last slide from Bruce, who will basically summarize what help they will give us in this effort. Bruce.
What help they will give us in this effort. So I think that's going to be one of the big questions, is what help is available, because obviously this is a new environment, it's not a traditional environment. So I think what I would communicate to anybody wanting to participate in the challenge is that we will provide documentation from Entry Point, from City of Hammond, to help you understand what APIs are available for your app, to be able to plug into the infrastructure and actually issue commands, to give it priority, to shape bandwidth and do those things. That we expect will be beneficial, but we also expect that we're going to have to do some hands-on support. So when you're working to develop your app, we will be available with staff to answer questions, to actually test the application on our infrastructure and try and develop an application that works the way you want it to work across this, what we feel is next generation infrastructure. So think of it as data center network to the home, again, kind of a cloud environment. You'll have both documentation, and you'll be able to reach out to us, whether it's Entry Point or City of Hammond, and get direct support from us to understand how to build your app.
Excellent. Thank you, Bruce, for joining us remotely. And with that, I'm going to change gears and talk a little bit about ParaDrop, which is the other important piece of this project.
And with that, I'm going to...
Okay. So, what you heard from Bruce and Jeff, it gives you an overview of the capabilities that exist in Amman. They're going to give you an infrastructure. Whatever you build can run on that infrastructure. The VBG gateway you saw, that was just a picture depicting the hardware. That looks different, but it will actually run in a nice little box. It will run in a box of this nature, which is a wireless router. And in the end, what you will program, or what we expect you to program, is software that you will write as mobile applications, as cloud components, and software that we will make it easy for you to run in those routers. Okay? And that is the capability that will be provided by ParaDrop. Okay? So let me tell you a little bit about ParaDrop in this rest of this presentation. So to do that, let me give you a very quick introduction to this concept, what ParaDrop introduces, which is called edge computing. Okay? So all of you are familiar with cloud computing. What is cloud computing? You have a few centralized data centers where computing resides. You have Amazons and Azure and other companies that offer this service, and you create a virtual machine and you run your service there, and that's all. Edge computing suggests that not all applications are best served if only a cloud-based data center is where your application endpoints can run on the infrastructure side. Some applications will benefit if I can sprinkle the same computing functions towards the edges of the infrastructure, like an edge network, which could be your home ISP network. Okay? So say your ISP is Charter or Cox or something else. You may have some computation, just like a virtual machine runs in the cloud. It runs in a server in the edge network. That's what edge computing is about. What are these kinds of services? So there's already companies like Netflix that are saying, well, if I put all my movies in Amazon's cloud, it's going to take a long time for the first few frames of the movie to show up when a person wants to watch a movie. So why don't I get some services that are the edge network, so that when somebody says, I want to start watching the next big show, it streams right away, it's faster. Okay, so that's an example of an edge computing service. Or if you're streaming some live event and your network bandwidth from the server to your home is not high, or in fact, if your bandwidth from the edge, say your wireless router to your device is not high, then I will on the fly change my bit rate so that I can match the available capacity of the network. Okay? These are the things you can do at the edge, because the edge point knows what's the rest of the story, what's the path to the rest of the network. So these are examples people try to do. What ParaDrop tries to do is to take this concept to the extreme. And we basically have been saying that take your home Wi-Fi router, okay, and make it into a cloud-like environment. So just like you create a virtual machine in the cloud, you create sort of a virtual machine in your home Wi-Fi router, and you can serve some things from there. And if we can make it really easy for somebody to use such an infrastructure, then it is very compelling, because some applications that require a millisecond or a few millisecond latency, you can host it there. Okay? So some examples people talk about are, if you want to do a VR video and you're putting on your headset, if the stream is coming from a faraway cloud, it's going to be very, very slow. It will not work. So if you can run it locally, you can make a good, you can make the experience good. Why the Wi-Fi router? So we picked the Wi-Fi router is because it's, firstly, today it's a device in your home that's always on. Hopefully, or I suspect none of you turn your Wi-Fi router off when you leave your room, right? We leave it on. So it's a running computer in some sense in your home. It has a low latency to everything in the home, and it's actually on the path from all your home devices to the cloud. So it's a natural point to put something. So what would be the kinds of services we would put on this router? It could be something like a smart energy management system, where, let's say I want to figure out, depending on who is in which room, I will open and close some vents, because I don't need to heat up every room when I'm not in that room. And for that, what do you need to do? You need to collect temperature data, you need to collect motion sensing data, and then you need to write some simple scripts to say, oh, when a person is in this room and this temperature is X, turn on the thermostat, change the vent setting, and things like that. I could do all this in a cloud server. I can put it in Amazon and send all my home sensing data to Amazon, and then put a VM that manages this. But that's not necessary. I can simply put some software running on my router, home Wi-Fi router, and manage this locally. Right? Simple thing like that could actually work very efficiently. Similarly, there are companies that sell you products that try to do video analytics to detect, is there an intruder in your home? If it's a baby cam, is your kid crying or something happened? So for that, what they do is the video camera will stream all the video to a cloud service, and then they do analytics, and then when something is detected, they will alert people. Well, some people are uncomfortable in streaming their home video all the way to anybody's cloud. Instead, if I can stream that video just locally to my home Wi-Fi router, okay. Now, of course, that means I need to have more storage in the router, but that's not hard, and our ParaDrop routers will enable you to do that. Then I can do the same processing locally and give you the same exact functionality without having to send terabytes of data to the cloud all the time, and also compromise my privacy. Because in this setup, now the video will stay locally in the home router. Okay? And we can do more interesting things. We can say, based on what I see in my video, maybe instead of using motion sensors, which are also very noisy, I can use my video feed to detect presence of people in rooms, and based on that, I will do vent control. So I can create new services by combining ideas and putting them locally in the router. Okay, so that's what ParaDrop enables you to do. ParaDrop doesn't implement those things. ParaDrop's a platform. So the name ParaDrop comes from the idea that we are going to parachute these virtual machine-like things, which you can think of as apps for a Wi-Fi router, onto a Wi-Fi router when I need it. On demand, I can put this computation into that. So we in ParaDrop will provide you with that infrastructure. You don't have to worry about that. You just provide your logic. Just like you put it in a virtual machine, you put it in this environment and it will sit on the router. Okay? And the way we think about it is that just like the iPhone came in 2007 and converted your feature phone to a device on which you can run apps, and they can be any apps. Apple did not think of all the apps. Everybody else thought about these apps. And it transformed that environment. We want to do the same thing for the Wi-Fi router. Today, the Wi-Fi router just sends Wi-Fi packets back and forth. I want to make it into an environment which is rich enough to build interesting apps. So it uses a form of virtualization, so that just like you go to Amazon and get a virtual machine and then put your code, you will essentially, through our infrastructure, get a virtual machine on a multitude of Wi-Fi routers and put your code. Okay? We will make it very easy for you. That's what ParaDrop will provide. So in a nutshell, it is a programming substrate on which we put these virtual machines. These are lightweight virtual machines. We don't want to run big, large VMs. We run what are called containers. In our terminology, we call them chutes to keep the ParaDrop parachute analogy. Okay? And just like virtual machines, they are isolated from each other. They have proprietary code. So what you write, you don't have to give me your source code and I will put it in. You don't need to share it with me. I don't need to see it. You just put it in the chute. It goes into the router. And our router will be equipped with multiple interfaces. For most applications, you may probably just want to use Wi-Fi, but our plan is to support multiple interfaces. We already support Bluetooth and Wi-Fi. We can also potentially support Zigbee. We have interest in doing other things like audio. And then we also provide some exciting wireless interference management capabilities that may be relevant to your projects, may not be. But that's what ParaDrop offers in a nutshell. So the virtualization technology that we use is called Docker. Now, some of you may be familiar with it. It's actually a very, very popular technology. If you don't know about Docker, I encourage you to go read it up. It's also another open source project. And it's actually become very, very popular to create these simple, lightweight images that can be moved around from different machines. So we use Docker because if you know Docker, you can very easily use ParaDrop. If you don't know Docker, I encourage you to learn about it. And if you use it, it will be very easy to use ParaDrop. By the way, I should emphasize that ParaDrop itself is an open source project, so you can use it, download it, and all of that. So overall, this will make it very easy for you to deploy these chutes. And just to give you the whole context, ParaDrop will run on the VBG router that will be in home. So for you, all you need to know is how do I program ParaDrop and deploy these chutes and use it. And underneath, it will give you a lot of capabilities to manage infrastructure and so on. So I'll give you a very brief example of how you can think of this system. So I should emphasize that when we say edge computing does not eliminate the cloud, right? You cannot say that I will forget about Amazon just because I have a router which will do my storage and computing, because the router is helping you to improve the efficiency. It's not giving you the same level of reliability and availability that the cloud provides. So you still need the cloud. If you have users and you want to manage user accounts and you want to manage credit cards or whatever else, you will not store that in the router. That you will store in the cloud. But anything that needs extra performance, that's where you use the edge computing. So for that, we also use a cloud service which manages all the routers we deploy, or that's running ParaDrop. And now imagine that for this competition, you're building something that uses your video cameras. Let's call them CCAM. It sees everything. You deploy this in a few homes, and that service itself will have another cloud service. So you still need a cloud service because you're managing user accounts and other stuff. And when you deploy these CCAM cameras into these homes, that's when the system will parachute the relevant CCAM chutes into the relevant Wi-Fi routers. That will be provided by our infrastructure. So you have to write the code that runs in that chute. You have to maybe build or use a camera. We will allow you to deploy them where it's needed. Okay? And now there is another entity or another team that wants to build something using temperature sensors or some other sensors in the home. And they deploy other hardware. It may be hardware, it may be some service running on a mobile phone that's running in the home. And they need to do something processing in the local environment. Then their cloud, that other team's cloud service, will deploy additional chutes in these routers, and they will coexist where it is necessary. Where it is the only one, that's fine. Okay? So that's how this infrastructure will overall work. There are lots of interesting examples. We have built some ourselves. We have done things like transcoding, which is taking a video coming in at, say, a high resolution video, and reduce its bit rate to a lower resolution because maybe the wireless link is bad. We have done implementations of this nature. We have done things like caching of movies in the router. I gave you the example of Netflix. We can do caching of Netflix movies in the router. Okay. Now you may wonder, is the router capable of doing all this complex computation? Well, the routers will be fairly capable. If you need even more capable services, we can probably look into getting you better, higher grade routers. So I want you to not be too much burdened by what you think of routers today can do, but think of what routers may do tomorrow in terms of computation, processing, and all these things. And we can get higher quality, better grade routers. Routers are only getting better every day. Okay, so I want to sort of getting towards the end of my presentation before we go into some very nice, exciting demos on ParaDrop. I'll leave you with the thought that you should think really big. Think of what all gadgets might be interesting to build something exciting. Don't be too limited, but don't go crazy. But I think there's a lot of possibilities in a smart home environment to use ParaDrop and lots of exciting gadgets to use. And there are additional capabilities that we will provide you. The Ammon team described to you the ability to control how to set up high bandwidth network paths in the city. And we will provide you the same capability in ParaDrop to say, well, you need to send a video stream from the home to the control station because there's a fire. Somebody's watching a movie maybe, I'll throttle that movie stream and that your stream will get all the bandwidth or most of the bandwidth. And we can control it and give you an API to do that. So again, these APIs will come to you just as a black box. You can say, okay, increase my bandwidth to 190 megabits per second or 1 gigabit per second, and you will get it. So that's sort of the API level support we'll provide you in ParaDrop. So with that, I would say that it's an exciting time to build this kind of applications. If you build it well, we will actually showcase it for you. We will take you to the best conferences to give you more visibility. Of course, there is cash awards and other things, but I think it's also a great way to build your resume to show what you can do with all these new and advanced technologies in the world of IoT, VR, network connectivity, applications in cloud and mobile and edge. Okay. So with that, I believe I'm going to hand it off. And by the way, there is on the website that you probably have seen in various emails, you can go and get more updated information about the competition. Our contact email for the competition is also available. It's paradrop.challenge.2017@gmail.com, and I encourage you to go build it. Okay. So with that, I'm going to hand it off to Lance Hartung, who is going to give you some real-world examples of how ParaDrop has been used and how you may go about building these exciting apps.
Thank you so much.
Lance.
All good, Derek? Good evening, everyone. Glad you can make it here. This last part of the talk tonight will show you some demos that we've built and talk about other projects that we've been working on with the ParaDrop platform.
Let me do this real quick here. Where is it? Full screen. There you go.
Okay, but first, as a developer on the ParaDrop platform, my personal goal is to enable edge computing, make it very simple with a very programmable hardware platform so that you can build incredible new applications. And how would you do that? So say you have some application code that you want to run on the router. You will probably require some libraries. For example, if you're using Python, you'll install some things with pip. You may additionally require some system packages that you would normally install with your package manager like apt-get. No big deal. You write up all of this in build instructions that tell ParaDrop how to prepare your application and then run it on the router. And then using our, as Subhan mentioned, it's like a package that we then drop onto the routers from the cloud, you can log on to our website, paradrop.org, construct your application there, then click install and you'll go to the router. So this is not just like an ordinary cloud server. There are additional hardware capabilities of the ParaDrop router. One of those is the management of Wi-Fi networks. This is a very interesting feature that you can build new virtual Wi-Fi APs so you can separate your network and have your private home network, put some other devices on another network, and then you can write chutes that interact with those devices on the different networks. And this is all very programmable. If you have some code that you want to use to control the network. So for example, we built the parental control application where you could say have your children connect to a private Wi-Fi network and then control what they're able to access, set up rules like no Facebook after 9 p.m. Anything that you can write code to do, you'll be able to do using our APIs. Suman also mentioned some interesting Wi-Fi and wireless network sensing capabilities. So in addition to Wi-Fi, we have Bluetooth and this unique research project that we did here in Madison called AirShark, where we can detect non-Wi-Fi sources, such as microwave ovens. So you can tap into the APIs on the ParaDrop router and find out what devices are connected via any of these different technologies and react to them with your code. So the software platform, you don't have to know how each individual component works, but at a high level, we have all these various services that run on the ParaDrop platform that you're able to access through APIs that the ParaDrop daemon, our software running on there, gives you access to. Interestingly, this runs on a little operating system called Ubuntu Core, which you may not be familiar with, but it's a very lightweight transactional operating system. When we release a new version of ParaDrop, it'll make sure that it completely installs that or it rolls back to the previous working version. So this is very suitable for running things at the edge of the network where we don't always have access to them. And finally, as Suman mentioned, we'll run your application code in Docker containers. You don't need to know a lot about Docker, but here are the key points. It's kind of like a virtual machine, but very lightweight. So a lot of the operating system and system libraries and other things that your many applications would use are shared between the containers. So the takeaway point is there's a low CPU overhead, low memory overhead. We can run many different applications on a ParaDrop router despite the low power platform that it's running on. And now I'd like to dive into some of our interesting demos that we have. The first one, as Suman mentioned, is suppose you have a security camera in your home and you want to do some analytics to detect when something is happening, when something's going on. We built an application for ParaDrop that runs a simple motion detection algorithm and then saves just those images. So what this looks like is you have a video camera connected to the ParaDrop router, and all the computation then occurs on ParaDrop and records whether there was motion, what happened, what's going on. So how do I switch it now, Derek? 5. So I'll switch over to take a look at.
Once you do 5, then you have to Alt-Tab to the browser.
Okay.
That one might be.
That's fine.
Okay.
Lance, do you want to mention where the hardware is, what are using?
Yes. Yes, absolutely. So we have a ParaDrop router here. It's just like an ordinary Wi-Fi access point, but with our software installed on it. It's additionally running software for this application that's running a web server. It's listening on the Wi-Fi interface to detect the camera device and pick up video from it. And then I have this laptop actually connected as a client on the Wi-Fi network as well. And because it's hosting a web server, I'll actually be able to access the information here from the web browser. this URL is going to go to the router and be resolved there and take me to this application. It's just a small mobile-friendly application that lets us interact with the software running on the router. So for example, we go to the live stream and have the camera here, and so we can see that the live stream is working. And then I mentioned there's a motion detection algorithm. So rather than storing the whole video on the router and wasting a bunch of space when nothing's going on, like right now, it's detecting when there's motion and only storing those images. So let's take a look at that. So if I go stand in front of here now and refresh this page, we'll see it took a picture of me. So let's talk a little more about how this application works. And which number is that? Is that 1? Okay. Yes. How this application works. So what we wrote for the router is a chute running Python code as well as some Node.js code. The Python code is using the Python imaging library to process the images that we get from the camera. And the Node.js code is just serving that small web app, as well as some APIs that let it fetch images and connect to the live stream of the camera. So
Matt, can people
yes.
write this in other languages too if they wanted to?
Yes, absolutely. Python and Node.js, we have specific optimizations in the platform that will make that easy. But we've done PHP. We have some compiled code from C that also runs on the router. Most things are possible. So a few key features of this application. One is, as I mentioned, it's doing some interesting network management. So there's a dedicated Wi-Fi network that the camera here is connected to, and it's separate from the Wi-Fi network that your laptop and cell phone and other devices would connect to. You may find this interesting if you don't trust all of the IoT devices that you buy from the store. Additionally, we demonstrated with this chute that it was possible to write some Python code and then run it on the router and have it interact with the wireless devices that are connected to your network. So when you try out other devices like a smart thermostat or a smoke detector, you'll be able to write code that talks to it if that's possible with your device. Additionally, this local processing feature, we ran the motion detection algorithm on the router. You can imagine if you had a lot of cameras in your house and they're all streaming video, you don't want to send all of that video to the cloud for processing. But you can handle it with modern Wi-Fi. If we're running these with 802.11ac that can get hundreds of megabits bandwidth, so you can run the processing locally, process the videos, and only save the key information. This is a very big benefit of using the ParaDrop. And finally, we demonstrated local storage, file storage. It's a nice secure local storage if you're worried about privacy and fast access. So stored the photos on the router and they were immediately available from the security camera web app. There's some obvious extensions to this that we're playing around with. You can do face recognition with the app. You could do send notifications to your phone when you're not at home. Obviously, that would require a cloud component. And as we're saying, it's not a good idea to completely eliminate the cloud, but there's some interesting stuff you can do at the edge alone. And finally, audio processing as well. Moving beyond just the cameras, we're interested in a lot of different home automation technologies, temperature control, lighting, playing sound, reacting to sound. And a lot of these have this characteristic that for responsiveness and reliability, you actually would prefer to have some edge computing. It's very frustrating if you have a so-called smart device that stops working because it couldn't connect to the cloud server. By running your code at the edge, you have a little more control to be sure that it's available and responding to the devices, and you can provide a better user experience. We really like the temperature control aspect. Suman, would you?
So I can take over for the next example. This we will not actually do a live demo right now, but we had done demos of this in the past. This is a very interesting service we had built for doing room temperature control using the exact idea I mentioned about controlling how airflow vents in a home may work. The problem is that in many, say 2-story homes in Wisconsin, your lower level is pretty nice and cozy in a winter day, but your upper level is cold, right? Your heat's not going up there well enough. And the problem is that the airflow to upper level sometimes is not as great. Your vents don't help you get the airflow up at the right amount. So this plot here shows on the x-axis you have time, y-axis amount of air flowing through the vents, and the blue line on top is the airflow in the lower level. Red line is at the upper level, and it's at about half the amount of air that's going in the upper level compared to the lower level, which causes this big difference between the temperature in the two levels. Now, what is a common solution people use? They will say, oh, just crank up the heat so it's good good upstairs, but then your downstairs is really bad. It's pretty hot. So we built a system based on ParaDrop where we deployed a bunch of sensors. We deployed a bunch of vent control systems where we put in booster fans that will increase the airflow in upper floors or increase the airflow wherever we want it. It's programmatically controlled. It's connected by that smart power strip. So when we supply power to that power strip, it will turn on a fan. If we take power off, the fan goes off, right? So it improves airflow in those rooms when we need it. And using all this system, again, you can imagine there's a bunch of sensors, bunch of actuators that we deployed to decide, oh, this room is too cold, I need more heat in the room, let's increase the airflow. Or that room, nobody's there, I will not worry about it, right? I can completely control this in a very fine-grained manner. So that was the system. The software was running on the ParaDrop router somewhere in the home, and it was managing all this infrastructure. And with that, we were able to get the upper floors to be much better in terms of temperature without having to crank up the heat. Okay, so you can see a little bit from this plot that the red line and blue line are much closer. It's not perfect, but it's at least gets the job done to some level. And what's more important than this picture is that we were able to save about 18% in energy cost, which is pretty good, while providing a better level of comfort in the home. In fact, more than the 18% number, I think the quote that really makes me feel good is the folks who were in this house said the master bedroom is amazingly warm and very comfortable, right? So it's not just saving energy, it's also improving comfort. And you can build this local system that can do something like this. Again, a simple system we have built and demonstrated, deployed in a few homes to demonstrate the capabilities that you can do when you have something like ParaDrop. Back to Lance.
Okay, so the camera demo demonstrated a plausibly good high bandwidth application. Next, we'd like to go to a real-time multiplayer game that demonstrates how effective the low latency communication at the edge can be for giving you a nice experience. Suppose your friends come over and you want to play a game with them. If the game is running entirely in your home and not going out to a server, then you can get a great experience and good performance. So for this demo, I have the laptop again connected to the Wi-Fi router, and another client, Derek over here, helping me, has my phone connected.
Bring the phone to the camera and see it, or?
It's the same.
He's going to bring up.
It's the same. We're playing the same game.
Yeah, okay.
Okay. And then the game server, the game logic is completely running on the ParaDrop router. Okay. Okay. So, again, this is a web application. So we just open up a web browser and go to the game's URL. Some of you may recognize this game. It's a It's an open source clone of a popular game called Agar.io. So the idea is you're a cell in a petri dish, and you want to eat the food and not be eaten. So you can eat things that are smaller than you, and things that are bigger than you might want to miss me. All right. I think the collision detection doesn't quite work, but you get the idea. So this is a purely Node.js application. It implements the game logic that computes the positions of the players and calculates collision detection, and then communicates with all of the players using WebSockets to send the updates and what's going on in the game. The web app client is just using HTML5 canvas to render the game and manipulate controls.
I wanted to add one
Yeah.
thing to make sure this point is made. I want to come in front of it. Right, you can continue. So I think it's worth mentioning that the two pieces that are running, the shoot is running on the router, and that's giving the very low latency. The shoot's running on the router, and that's giving the very low latency experience. The two devices can interact with that software that's controlling the game in a few milliseconds, and you really experience this nice environment. And then the web app is running on the mobile device. So that's really the two pieces that's built for this game. And I think if you were to run the shoot in the cloud instead, you would be dependent on the latency between the cloud and your mobile device, and the experience is not likely to be that fast, right? So it shows the advantage of using very low latency. Now, we showed you a game just to give you the sense of what you can do, but imagine what other applications can take advantage of it.
Another interesting point about this application is we didn't write the game code, and we didn't even modify it to run it on ParaDrop. We found it on GitHub. We went over to our ParaDrop dashboard and told it to launch this shoot, and it worked. Now, I did tweak the settings in the configuration file before the demo, and I did change the title, but really, it's just a Node.js application web app. And if you write something in Node.js that's also a web app, it'll run on ParaDrop with no modification. Again, to reiterate what Suman said, this is a really good test case for a highly interactive application. It leverages the low latency that you have with just the local Wi-Fi communication. And we're really situating this for the future, where you may develop video-intensive applications such as VR, where that high bandwidth local link is very important. And finally, as we mentioned, there's no app installation. It's just a web app, so you open your browser and you're good to go. One last point, I found this interesting when I was testing it, is actually the CPU sharing when the game is active versus when it's not is really great. So we have a total of 3 applications installed on the router right now. When I joined a game, it did use up a lot of CPU calculating positions, but as soon as I left the game was idle and background tasks were able to run unhindered. So this is partly because of our use of Docker, very lightweight containerization, but it illustrates the point that you can have many applications running on the router, and they will share it quite fairly. And finally, I'm really excited for this demo. We have another game. For this one, we're using a separate display and controller. And I think you have your own slides for this.
Here's the slide. Here's the slide. Okay, I'll do that. So as you saw from the first slide, this project I got Nintendo 64 to run on a ParaDrop router. So I started on this project by asking what kind of applications are most benefited by fog computing, like or edge computing. So we'd already talked a lot about, sorry?
What is fog computing?
Fog computing, it's like edge computing, right? In the sense that the cloud is something that's ephemeral and lives far away. The fog is also ephemeral but lives a little closer. I'm not sure I guess fogs are closer than clouds. Edge computing, as we had said before.
Fog is the same as edge for
Yes. So previously, Suman had talked about gigabit applications, right? Those are applications that require very, very wide bandwidth, high bandwidth, that can benefit from running locally, right? Where you don't want to go all the way to the cloud and back. The other broad class of applications that really, really benefit from being local are latency-sensitive applications. So the previous demo that we had shown, Agar, traditionally runs on a multiplayer server, right? So both two players connect and talk somewhere to the cloud. Now, people who make video games have struggled for a very long time dealing with that kind of latency. Here, what we're going to be doing is one step further. Here, the Nintendo runs on the ParaDrop router, and we use a smartphone as a controller, right? So the input lag has to be very, very low for the user to be able to use it seamlessly, easily. So as the idea kind of bubbled around, I looked around on the internet and saw what I could find. So the emulator that we're running here is called MUPen64 Plus. It's just taken from GitHub. It's written entirely in C++. It works on a plugin system. So a lot of people wrote their own video plugins for how to get information in and out of the emulator. Seemed a little complicated, but it looked feasible. And finally, used an Ionic app as a controller. Right? So the user has the app. They use a web browser to navigate to a page, and the ParaDrop router runs the game and shoots the stream to them. So this was kind of tentative. This was still as I was brainstorming. The reality of it ended up being a little bit more complicated. So this is the architecture of the application. Now everything here is run off the shelf. So it's not, if it looks complicated, it's not because anything I did. Right? I just glued all the pieces together. The way that this works is the router presents a web page to the user through the browser. We're calling the display here. And it takes the emulator, which is up here, compiles it to JavaScript and serves it to the user. Now, the user can open the iPhone app, which is shown here, and then use a library called WebVR to recognize gesture and button input, which we then pipe back to the emulator, right? So the problems with the beginning, the reason that we ended up going with something like this is that the C++ in the original emulator is very complicated. So what the current state of the application is that you connect to a web page, you get the N64 screen, and then you have your phone connect to a different web page and have it work as a controller, which is what I'm going to show you now. The stuff that I didn't get to do is multiplayer and lobbying, which seems like it'd be reasonably easy to do, just didn't have time. So here's the web page as it appears. If you go to home.paradrop.org, well, yeah, this is where the web page is now. There's a prettier name for it too, but it seems to have gone away. This is what you're presented with. So this is the display. So this is served from the router. And unfortunately, strangely enough, it's legal to use the emulated Nintendo here and host it and give that code to you guys. But it's not legal to have games. So I actually had to go find a cartridge of Mario Kart so that I could use it for this demo. It should be loading here. There it is. And then I have on my phone the app. This is the controller. I used an NES controller because I was a little worried about the N64 controller. It's a little funny looking. Right? So if I sit here, can I bring that up here? Can I bring the camera instead on the screen?
Press 5 and then the item you'll see. 5 switch.
Awesome. It's the A button. All right, we're going. So the interesting part about this app, or one of the more interesting things about this app that I wanted to do was to use the gesture controls like I showed you before. So the keyboard as shown here, sort of shown here, the controller as shown here has all the buttons that work, right? So all the inputs from my phone go to the router and then go to this game stream here. So I can choose a game mode, pick a character, whatever you like. But I'm using the smartphones I'm using the sensors on the smartphone to also do gesture recognition. So in addition to just pressing A, I can just go forward by moving my smartphone forward, or go left and right by tilting it left and right. Now this is meant to be toyed with. This left and right, forward and backwards, I kind of settled with as demonstrations, but my hope was that the gestures would work, that the people would find more interesting gestures to use for these games that, no one was thinking of doing gesture recognition 20 years ago. Quickly play a little bit here. Just a little zoomed in. Alright, so I'm pressing A, so I'm going forward. I can also go left and right here, using the buttons on the smartphone, or tilt, which is a little touchy, but should be working. I'm going to turn and hold the phone up so it's a little easier to see. Slow and steady. So conceivably, if you're running this in the router, right now it only supports one person playing a game and one person in that game at once. But it should be able to handle multiplayer. So a way in which you can see this working is you open up a browser window as a display, and then have your friends crowd around it with their own smartphones, each one working as a controller. Or you could have multiple computers in the house, both displaying the same game with multiple people using their own controllers. Or having multiple games, separate games, with multiple people on each of them, or single people on each of them. There's really no limit here, because this is running in the browser. That's all I have.
So,
I didn't use it. I'm Mickey, by the way.
Mickey Barboy, who also works with us on the ParaDrop platform and team. And should we go stop that? Okay, so that's what ParaDrop is all about. I think it's an exciting platform. We have built it so that you can create new things on top of it. We showed you the games because they are easy to understand, but we want you to build more exciting things, useful things. As I said, it should be public safety or education for the purpose of competition. But if you have a great idea that's different and it's useful, we will definitely encourage you to propose that to us. Talk to us, send us email, and we will allow it if we like it, for sure. And you get a chance to interact with the folks at the City of Ammon, because you can deploy, you can imagine with these capabilities what else you can do in a home. In an emergency situation, I can use this kind of controls with a local gateway to provide us some unique services, right? So that's all I had, or we all had for today. I wanted to introduce to you again the rest of the team members here. You saw Lance Hartung and Mickey Barboy. We have Derek Muir, who's also been an integral part of this team. Is Peng here? Peng Liu, grad student working on a lot of the parts of the ParaDrop project. Dongjin Su, grad student, and Sajal Chauhan. And I hope I didn't miss anybody. I think that's all. And I also wanted to thank the team from Ammon, Bruce Patterson from the City of Ammon, and Jeff Christensen from Entry Point. Thank you for joining us. And at this point, I'll be happy to take questions if there is any. The floor is open. And thank you to all the people who joined us online live. And with that, we sign off here. Feel free to enjoy more cookies and send us your entries. Thanks. Thank you.